Well, really the idea of today with our customers and partners is to help them achieve their very challenging targets. When we talk about all types of industry, but especially the automotive industry, there is a specific context where we want to save time and money before the first prototypes and the controls are validated. And really, this is where we believe that what we call the digital twin can help. So what is the digital twin? Well, when you are working with organizations, you can see that there are many types of data that are in silos, I would say, that are not structured, not organized. And if you smartly make sure that those data are interacting correctly with each other, you can create what we call simulation equivalent of a final product early in the design cycle. And by doing this, help manufacturers, OEMs, to design better products much faster. So why do they want to do this? It's because they have more and more complex products to be designed, and also those products that are complex, they have many attributes to be trade-off. You know, there are regulation policies to make sure that the world ecology is sustained. We need to make sure that the vehicles are more and more comfortable, more robust, more safe, and are also cheaper in terms of usage for the customers. So really, the idea of that digital twin and what we call the model-based systems engineering is to make sure we can help our customers and partners to trade off between those different attributes. So those different attributes are what? Fuel economy, performance, but also drivability, that is to say the mechanical comfort of the passenger, also the thermal comfort of the passenger, and also towards advanced driver assistance system when you have more and more active systems that need to be controlled. And if you have to balance all of these subsystems together, it's very complex, and the digital twin can help for that. Let me give you a very recent example on which we worked with Renaud and Nissan Alliance. Those guys, by 2020, they will have to be able to characterize very accurately what is going to be the emissions in terms of CO2 and also the fuel consumption of the fleet of all their vehicles, meaning all the variants for any types of architectures, might they be conventional, hybrid, electric, or even fuel cell. And for that, you have to use thoroughly and a lot simulation controls, but also in order to make sure you can run those tons of analysis and simulations to get the results, you need also to prepare the simulation model with dedicated graphical user interface, simplified workflow, such that you can very easily define all the vehicle architectures, parameterize them, define all the scenarios, export the simulation on HPC targets, get the results, analyze, and provide the results to the management. Because by 2020, each gram of CO2 that you will produce will cost a lot of money. So that's how I believe, or we believe, Siemens, its methodology and tools, the digital twin, and also the system-driven product design vision can support our customers worldwide in reaching such type of objectives. Market is changing very fast, and when I started 20 years ago, simulation, at least system simulation, was in its early design stage, I would say. The simulation is now more and more deployed within the industry. Might it be for the physics, but also for the control, because physics without control is almost nothing. And I would tend to say that studying mechanical engineering or fluids engineering is something is very important. The physics is important, or understanding and being able to create the equation is important, but mastering the models that use that physics in order to help the world use those models and tackle some specific objectives that are very complex much more rapidly, this is the future. So if I had to give an advice, well, do not forget simulation. These tools can be used by any type of students, but the one that is going to take the most out of this kind of tools are the students working on mechatronics system. That is to say, really the connection between the physics and the control that is going to bring intelligence to that physics, I would say. If you go further towards system-driven product design and the connection between systems engineering and system simulation. For systems engineering, this is more the IT engineers that might be interested in such type of tools. Yeah. But mechatronic and all the students that are working on the physics, fluids, thermal, electrical, mechanics will certainly have a strong interest in using those tools, especially for their future jobs.